to a casino.
I'm not trying to tell you not to gamble. I'm trying to have you understand this is not the way to make money.
My boyfriend was.
This is the way to have fun. This is like going to the movies.
I walked out.
You go to the movies, you pay them 20 bucks, you get some popcorn, you get a ticket, you sit in a darkened room with a great sound system for 2 hours. Watch a bunch of previews, it's all good. At the end of the day, you go home and you have that experience, but that costs you 20 bucks. Yes? Gambling is much the same way. You just paid 20 bucks as a team. 20 bucks as a team. You had the experience of, well, I gave you Starbucks too. But you had the experience of gambling, sitting in a casino, having a good time, being surrounded in kind of an alien environment. So think of that as the price you pay for that. Don't think of it as an investment. Thank God lotteries have started putting that on their billboards. Do not play for investment purposes. Because I think people get so caught up in it, and Powerball doesn't help. Powerball, there's so many ways to win, as you mentioned, there's so many ways to win at Powerball. But it's not likely, but believe it or not, if the jackpot gets high enough, and I haven't been able to measure this yet, if the jackpot gets high enough, and I forget the definition of high enough, I think it's $750,000, or no, what was the record recently? 500 million or something like that. It was very, very high, extraordinarily high.
It was almost like
800 million, ridiculously high. The past year has shown these exponential almost increases. When it gets that high, and here's a condition, when it gets that high, and you're the only winning ticket, this average actually turns positive. I haven't calculated the exact break-off point. It's somewhere around $600 million. Now it gets that way. It's gotten that way a couple times in the past couple of years, if you remember. You know, what's about on the news? Right now, I think it's about 100 million right now, or somewhere along that line. But you hear about it when it creeps up over $500 million, something like that. All right, that's when this actually goes from negative to positive when you calculate the average. The problem is that assumes two things. Number one, you don't pay taxes on it, which you do. As soon as you win, you lose half of it.
Right.
Half goes to taxes, almost half if not. And that's just federal tax. There's also state tax. And number two, almost inevitably, when the jackpot gets that big, you aren't the only one that wins. They often split it two ways. So what was positive in theory becomes negative by default because of what happens with human nature, because more people play when it gets that high. So that's the idea of analyzing these things mathematically. You can figure this out before you go in. What we just had to do to calculate this number, which is awesome by the way, we had to play the game 230 times, 240 times. It'd be nice to not have to do that, and we're going to show you how to do that momentarily. But for starters, let's approximate our chance of winning. Okay, experimental chance of winning. All right. So we're going to do it theoretically and experimentally, and then we're going to call it a day, because I think after we do the theoretical calculation, you'll be ready to get the hell out of here. I can erase this, yes? I think. We don't need this because it's over there. Okay. Now this is only the chance of winning on a pass line bet, which is what you guys just did. This is not betting on 11s. There's like a boxcar bet and a yo-yo 11 bet. There's a snake eyes bet. There's all kinds of fun bets you can do besides this one. But this one is the one that makes me, I mean, imagine betting on snake eyes, right? When it pays out great. But it only pays out 1 in 36 times on average. Micah?
So doesn't each additional bet lower your odds of winning?
If you look at, thank you for that. If you look at the table image on the front page of this quiz, if you look at that table image, in the middle there, 5 for 1, 7, 5 for 1, 10 for 1, 30 for 1, 15 for 1, and so forth and so on. Those are the payouts, 30 for 1 payouts. So check out 30 for 1 payouts. You get 30 for 1 payouts if you bet snake eyes or if you bet boxcars. And that sounds very generous, right? If you bet $1, they give you 30 back when you win, correct? But on average, how often does snake eyes show up? Once every 36. We calculated that on Wednesday, which means you're going to get back your bet of $30 every 36 rounds on average. But you're only paying, you've paid in $36 and gotten back 30, which means you're down 6. You see the problem with this? And that's how they're all controlled. They use very nice round numbers like 5, 10, 30, 15. Very nice, very nice. But they've got it controlled because the dice fall a certain way. Do you ever notice that the pit bosses are always pulling the old dice out, drilling holes, and putting new dice in? They want to make sure there is absolutely no advantage given to a player because of the dice even becoming partially rounded and maybe showing 7 more than they should. Yeah, pretty amazing stuff. Mike, does that answer your question?
Yes.
Fantastic question. Analyzing this game is great. Let's do probabilities. What's the probability winning on a pass line bet. And we're going to do it two ways. We're going to do it two ways. First is experimental, which is what we just did. Again, experimental. Hold that thought, Andrew. Thank you, sir. Now, we know how many times we played. We played 240 times, yes? Those 24 of us played 10 games each. Now what we have to do is go into your quizzes and count up all the wins. So if we could, to expedite the process of this, could one person from each team just add up all the wins that you circled? And then we'll report back on that. We'll add those up and stick them over the 240. Does that make sense? Everybody see what I'm saying? So one person just give you the sum. So Andrew, we got 9. 10. Cool. Let me go in this way so I don't, me and counting. It's like the ADD mind doesn't do it very well. Okay. It can juggle 8 things, but it can't do one simple thing like count and add as we go. Thank God you guys do. We got them? Okay, let me go around the room. We got 9.
8.
That's 17.
7.
That's 24.
5.
29. 39. What do you guys got? How many wins do you have?
What?
How many wins do you have?
Oh, I have 10 total.
10 total? 49?
9.
We have 9, so that's 58. 68. 78. 85. And the 9, which would be 94. Thank you. Whew, here's the 10, Sean. All right, friends. 94 out of 240. Micah.
11.
11. 95 out of 240. Thank you, sir.
Sorry.
Don't be sorry. 95 out of 240. As a decimal, Hassani's on it for me. What do we got, Hassani? 39%-ish, somewhere in there?
Depends on where you're rounding.
Let's round it to 2 decimals. Make 30, is it 39 or 40? It's 40. That's actually worse than it should be. It should be higher than that based on pure chance. So we actually did worse on average as a class than we should have, but that makes perfect sense. Because in the future, some class will do better than they should have, and that'll balance to right about where they should be. So Vegas is not going to use that probability for the pass line bet, because they would be penalizing people too much. And if they penalize people too much, what's going to happen? They will not play the game. They will not play the game if people are penalized too much. This is almost 10% off. So what I want to do now is I want to analyze the game theoretically to see what odds Vegas actually uses. Swing this over to here. Okay, you guys ready? This was our last calculation as a class. That's kind of sad. Tear.
We'll be back next year.
I don't know. We'll be back. Okay, here we go.
I don't know.
First of all, let's write out. Ariel, go ahead. What's in
We
mind?
were just wondering, we're here on Wednesday, right?
Oh, we are, but this is the last. I'm not going to lecture on Wednesday. We're going to have homework due for Wednesday and a project due. And then we'll just wrap up and we'll talk about your exam and call it a day. I mean, I could keep teaching, but it's kind of dumb to do that, I think, I personally think. Actually, I lied. We have 2 calculations, so I feel better now. This one and one more. So, here's the deal. How can you win in a pass line bet, or for a pass line bet? How can you actually win? There's 2 ways, right? You can either win on the first roll, or you match your point before rolling a 7, yes? Or you match your point before you roll a 7. Notice I'm not talking about snake eyes or craps or anything like that, because that's losing. If I can analyze how likely it is to win, then by definition I'll also know how likely it is to lose, because it's whatever's left over. Because right now we think we have a 40% chance of winning, that would mean we have a 60% chance of losing. Now we do not have that. We do not have that. But that's what it looks like based on our data. Now also, I'm going to take one quick pause and go over here. I'm going to come back to that theoretical. I want to mention our 40% again. This 0.57 can be gotten in a different way. Check this out. I'm going to do some, this is part of 243 as well. It's called a probability distribution. Now this is great, and I think we all pretty much understood it as far as what we're doing, averaging our results. But if you know off the bat what the likelihoods are in your game, so if you have a 40% chance of losing and a 60% chance of winning, then you can analyze your payouts mathematically in the same way. So check it out. When you lose $1, yes?
Yes.
You lose $1. You lose your $1. When you win, you gain nothing. You don't get anything. Everything. Andrew?
Isn't it reversed? Don't you lose 60% of the time? You win 40%?
Oh goodness! Yes, thank you, Andrew. Thank you, sir. I had it backwards. Thank you. I had it backwards. When you win, you don't gain anything. But when you lose the $1. Thank you. Thank you, Fred. So, in other words, all of this can be deconstructed down to just this. It won't be exact because we were off by that 10 in here somewhere. I miscounted somewhere in here. But watch this. We can do the exact same average right here. This times this, 0 times 0.4 plus -1 times 0.6, all over this times this, or that plus that, which is just 1. So we added up all these right here. That's like adding probabilities up. What does this all add up to? -0.6. So we could have gotten right to that -0.57 without having to go through all of that adding and losing of money. We could, if we have the probabilities in the beginning, we can go straight to the average and know how much we average. That's the beauty of probabilities. That's what I'm going to come back to with the theoretical. Now that's a little bit off. It's a smidge off because I miscounted somewhere in the results, and I apologize for that. It would have been perfect had we had everything perfectly. But if we can get the perfect probability now, see, here's the deal. If we can get the perfect probabilities that go here, we'll get a better idea of what the average should be. This is too low. It shouldn't be -60. It should be higher than that. In other words, losing less money. So let's come back up to here. And let's calculate this. All right, here we go. Back out a smidge. What's the chance you win on your first roll? Who figured this out?
Did we do this last week?
I think we did it. I think we did it last week, yeah?
22 or something like that.
I'm here 22%. That sounds right to me. Because how do you win on your first roll? Either
7 or 11.
a 7 or 11. How many ways can you roll a 7? 6. 6 and 1. 1 and 6. 2 and 5. 5 and 2. 4 and 3. 3 and 4. But you can also roll an 11 to win. And how many ways can you roll an 11? 2 more. 5 and 6. 6 and 5. So there are 8 total ways. Out of how much? Out of 36. That's the chance of winning on the come-out roll. Your first roll, you're going to win. There's your 22. Thank you. There's your 22%. So you already have 22% in your corner before you even start playing the game. Actually, before you get to the first roll. But here's the deal. You can also win later on if you don't do that. Fair enough? So, or you'll learn this in 243 more. Always means to add when you're talking about things that can't happen at the same time. And that should make sense logically. Our probability has to go up because we're increasing our chance of winning by giving us more ways to win. So we have to add to that, yes? Does that hopefully that makes sense? I'll plant that seed in your mind for 243. All right, now here's where it gets interesting. Match the point before rolling a 7. So give me an example of that. Give me an example of how you guys matched a point today.
If you roll 4.
If you roll a 4,
And then if you roll another 4.
and then you roll another 4 again, but don't roll a 7. So let's break that down. Nick just gave us actually 2 probabilities right there, believe it or not. The first thing he said was, if you roll a 4, what is the chance of rolling a 4? How many ways can you get a 4? 2 and 2, 1 and 3, 3 and 1. 3 ways out of 36. That's the chance of rolling a 4 on the first roll. Yes? That's the chance that you roll a 4. This is the chance you roll a 7 or 11. That's the chance that you roll a 4 on the first roll. Andrew?
I was just thinking, couldn't we just do this backwards as far as figuring out what's the likelihood of rolling a 7 after you roll?
It's trickier that I've tried it both ways. It's actually no less work. and it's slightly less intuitive that way. I'm going to have you analyze that using Excel on your take-home. Andrew's saying come out of the back doorway, which makes a lot of sense a lot of times in probability, but you don't gain anything by doing it this way here. I always think of that. To give you an example, if I ask you guys when you were born, which I'll do in 243, there's a pretty good chance that 2 of you in this room have the exact same birthday. With 25 people in a room, it's almost 50-50. Almost 50-50, believe it or not. And calculating that, though, directly is a nightmare. But calculating it around the back door by what's the chance nobody has the same birthday is actually very easy. We'll check that at the end if you want. But here's the deal, though. Nick's given us the chance of rolling a 4 on the first. What's the chance we now hit the 4 again before hitting a 7? And this is where it gets tricky. There's still 3 ways of hitting the 4. 2 and 2, 1 and 3, or 3 and 1. But what are you interested in now in the denominator, in the sample space? For example, if you roll an 8, does that matter? No, when you rolled an 8, you just ignored that roll, correct? If you roll a 9, does it matter? If you roll snake eyes, does it matter? Not now, it doesn't. If you roll boxcars, does it matter? If you roll 3, does it matter? If you roll a 7, does it matter?
Yes.
Yes.
Yes. So the only outcomes you care about are either rolling a 7 or rolling a 3 again. So you've got 3 ways to roll a 3, yes?
3 ways to roll 4.
3 ways to roll a 4, thank you. 3 ways to roll a 4. And how many ways can you roll that 7?
6.
6. That's your new sample space. That's all you care. That's where it gets tricky. That's where this computation gets a little tricky, is that sample space right there. The 8s don't matter, the 9s don't matter, the boxcars don't matter. Nothing matters except the 4s and the 7s. That's all you care about. And I know this is a little bit squirrely, and I would never expect you to regurgitate this on your in-class exam next week, but I want you to understand. Hassan, go ahead.
6 or 8.
It's 6 ways to rolling a 7. You're thinking of the come-out bet, which is 7 or 11.
Okay.
We'll take the 11th one. If you're rolling 11 in the point round, doesn't matter. This is me. Thank God me and Sheldon were going back and forth because she was catching me whenever I screwed up. I'm like, oh, it's 11. She's like, I don't care, it doesn't matter. All that matters is the 4 and the 7. But that's the way of getting 4s. How else can you win on points? How else can you win on points? 5s. Let's tack that on. Keep adding your... This is what Nick said. This game is great because there's so many ways to win. Yes, there are. Yes, there are. How many ways can you roll a 5? 2 and 3, 3 and 2, 1 and 4, 4 and 1. Di's got it. There's 4 ways in 36 of rolling the 5. That's the chance of you rolling a 5 on the come-out bet. What's the chance of you rolling 5 again before you roll 7?
It wouldn't be 11.
Well, you still have 4. There's still 4 5s over 4 plus 6. Because you have those 4 plus the 6 7s, those damn 7s. That's what makes the game of craps weighted for the casino, is those 6s each time down here. Do it again? Because now we got 4s, we got 5s, we got 6s, yes? 6s would be 5 and 36. That's a chance of rolling a 6. Times. Now the reason I'm multiplying might not be obvious. It might not be obvious, and 243 will drive this point home to you. In 243, you learn that OR means to add, and the word AND means to multiply. And you might not have caught what Nick said earlier, but he says, well, one way you can win is to roll a 4 and then roll a 4 again. So when you sequentially talk about sequential events that have to happen one and then the next and then the next, you multiply. These events can't happen at the same time, can they? Either this happens or that happens or that happens. They can't happen at the same time. But the ones in here do happen within the same round. We're multiplying those bad boys. All right, 536 times 5 out of? 5 plus 6. Yes. And it gets better. It gets better. Because we can still win more ways, can't we?
Yeah.
We can still win with 8s, 9s, and 10s. Yes. Now the beauty of that is these start repeating themselves. The chance of winning on 8 is the same as the chance of winning on 6. Well, it looks like 5. This is actually 6s, yeah? Because there's just as many ways to roll an 8 as there are to roll a 6. This is where last class comes in handy when you have your distribution. And Di's looking at it right now. She's looking at that distribution from last class. There are 5 ways to roll an 8. Double 4s, 6 and 2, 2 and 6, 5 and 3, 3 and 5. Yeah? So the chance of rolling an 8 is 5 and 36, and the chance of following that with another 8 is 5 out of 5 plus 6 again. Yeah. which is just 11. I'm putting 5 plus 6 is just 11. The chance of winning on 9s is the same as winning on 5s, because there's 4 ways to roll a 9. 4/36 times 4 out of 4 plus 6. And the chance of winning on 10s is the same as the chance of winning on 4s. Your job right now, calculate that. Yes! Calculate that. I'll do it too. Let me log on. Just pause the camera momentarily. Because once you have that,